Good morning, everybody. I have a problem where expressing the roots of a quadratic as the coefficients is quite useful. It's called Vieta's formula, and let's just write this down. Let's say that capital A is a root and capital B. And I'm just going to literally write it down. Anytime you have a root, you have a corresponding factor, right? So if we have two roots, A and B, okay, I'm using capital A, capital B here. So again, just by the way this is being written, A and B are roots. X equals B and X equals A make the entire expression equal to 0. Okay, now this can be rewritten equivalently, and again I'll put double arrow here. Okay, if you expand this out, you get x squared and then it's this useful sort of, I don't know how to, representation, I guess, minus the sum of A plus B is actually the coefficient of X. Okay, and you see the minus sign stick because it's really minus A plus minus B. And so we go ahead and write that in factored form as the coefficient of X. So right here you can see that the sum of the roots is nothing more than minus the sum of the coefficient here. Whereas this expression right here, A plus B, is the sum of the roots. So minus the sum of the roots is the coefficient of X. And of course, the very last part of this, minus A times minus B is plus AB, right? Equals 0. Again, this is just the quadratic form of what is often called Vieta's formulas. You don't have to know that it's called that. You just have to have the sense to write this down. Okay. So again, important product of the roots right here, minus the sum of the roots as the coefficient of X, okay? Now here's our original problem, and what we do is multiply through by X plus Q times X plus P. When you do that, you get this equivalent equation, okay? And again, the rest of this I won't spend too much time on. You just multiply everything out, get everything together, and you get this standard form right here where you can see that P plus Q minus 2R would be the sum of the roots, okay? P plus Q minus 2R minus that would be the sum of the roots, okay? And then this entire object right here is the product of the roots, which is what we're looking for, right? So the product of the roots, which is this constant term here, which is 3 terms actually, can be rewritten this way, okay? So we have the product of the roots written in terms of P, Q, and R. Now y'all, R up here is just a unknown real constant, a non-zero unknown real constant, all right? It doesn't mean root, which is a little confusing, okay? So let's go on down. Now the sum of the roots, okay, is this, just like I said before. You see the minus sign, okay? So you have to apply the minus sign, okay, to this object that's in front of X, which is exactly what I do right here, okay? Now, if we'll let A and minus A be the two roots. Now that's motivated by the roots are equal in magnitude, but opposite in sign, right? Equal in magnitude, but opposite in sign. I prefer just to use what we need as we go along rather than read the whole boring problem to you, okay? So the sum of the roots is equal to this, but minus A plus minus B is certainly equal to 0, right? A plus, I'll write it this way, friends, A plus minus A certainly equals to 0. Y'all, that's a miserable A, isn't it? But that's certainly equal to 0. And so when we set this equal to 0, we get P plus Q is equal to 2R, okay? When we set the sum of the roots equal to 0, we get, that's easy to show, P plus Q is equal to 2R. All right, and then right down here, we're almost done. Notice that this would mean the very same thing as P plus Q over 2 is equal to R, right? P plus Q divided by 2 is equal to R. Okay, and you can see at this very next phase of the problem, all we did was substitute that. All right, we replaced R, this R right here, with this R right here, and that's how we ended up with P plus Q squared, P plus Q quantity squared over 2. Now, I'm sure you guys can see it, but what happens right here is you have the PQ. Now notice that, and I'll just write this out, it's probably unnecessary, but if you have P plus Q quantity squared, that's a well-known binomial expansion, I guess. P plus Q quantity squared is certainly equal to P squared plus 2PQ. The 2 is important here, plus 2PQ plus Q squared. Okay, so you can see that what happens here, this 2 cancels with this 2, leaving a plus PQ, which cancels out, you see, because there's a minus sign in front. Okay, there's a minus sign in front of this. Okay, so again, this 2 would cancel this 2, and since there's a minus sign, there would be a minus PQ canceling with this plus PQ. So this circled part is the answer. Interesting problem. I like it quite a bit. And let's see if the way this JEE test is done, they give you, it's a multiple choice test, okay? And so anyway, choice C is certainly the answer to this problem. Choice C is the answer to the problem, and let's see, do we keep it on the screen? Probably not. Anyway, there it is down here. This is the whole 9 yards. And again, y'all, I did like this one because if you can write this down right here and see this, you don't have to memorize any formulas. You can see exactly how the zeros or the roots are expressed. A and B are roots. When you expand this out, you get minus A plus B, which is minus the sum of the roots as the coefficient of X. And of course, the product of the roots remains as the constant. All right, so you just have to be aware of that as you're marching through this problem. And we get a quadratic in standard form that has a complicated complicated coefficient of X, but just minus this object has to be the sum of the zeros, whereas this object all by itself is the product of the zeros, and that's the truth that we used as we worked this problem. Hope you enjoyed.